Hello and welcome back. We're ready for our third and final section of the urinary system. We got all the way through talking about the release or the management of metabolic waste and how our body removes those. Being just just to complicate things, right? We talked about the solute gradients and we talked about the acid and base balance. And the last couple of things that I want to talk about are ways that we can manipulate how our body system works and what happens when the kidney system doesn't actually work. First off, I want to tell you a little bit about diuretics. Our brain, our pituitary gland, is going to release a hormone called ADH, which is the antidiuretic hormone. This is designed to decrease the flow of urine. It's to retain water inside of our nephrons so that we aren't producing as much water or we're not releasing as much water. That's a normal situation. And that's what should be happening. That's why every time you go to the bathroom and you pee, more often than not, you get some yellow color to it because there's more urine, there's more that urea waste product in there. However, there are some chemicals, some of them which are called diuretics, which counteract the ADH, the antidiuretic hormone. This is going to do the opposite feature, which is now going to cause us to release more of that water, and you end up peeing out more of a liquidy, more of a water-looking substance when you go to the bathroom. Simply put, it increases the flow of urine. And there's a number of different ways that we can work with diuretics. One of the most common, or in fact, two of the most common diuretics are alcohol and caffeine, which end up being two of the most common consumed products in North America. I'm going to start by talking about alcohol a little bit. Alcohol is an interesting one because quite often when people consume alcohol, there's a misconception that they're peeing out the alcohol after they have, say, a beverage or they have anything that contains alcohol in it. What's actually happening is that alcohol is still in the body system. It's doing whatever it's doing elsewhere in the body, quite often at the liver and then in other places also. But your body is losing water. You're peeing that water out. That's why you have to go to the bathroom after consuming even a small quantity of that diuretic compound. A very common symptom that people experience after drinking, quite often the morning after drinking, especially if it was heavy drinking, is what's called a hangover. They experience these strong headaches, painful headaches, they see spots, they feel nauseous. And we got to kind of understand what that actually is. Simply put, it's dehydration. That's really all it is. And if we walk back slowly, we can try to understand why that makes sense. If you have a diuretic in your system, in this case alcohol, then you're going to be going to the bathroom frequently. You'll notice if you have an alcohol in your system, you end up peeing out significantly more than you drank in. That's because you're losing your water reserves. So your total water concentration is starting to drop. If your water concentration drops too far, you start to feel thirsty, you get a dry mouth. If it gets very, very badly, if you get very thirsty, then you start to see spots, you might get a little bit dizzy, that sort of thing. But all of that is impaired while a person is consuming alcohol, while they're under the influence of alcohol. So they don't realize they're as thirsty as they are, and they don't realize that they are as dehydrated as they are. The other misconception is if you're thirsty, so let's say someone's only had a little bit to drink and they still recognize they're thirsty. The other misconception is the only thing you need to do is drink to counteract thirst. That's not true. You need to drink water to counteract thirst. By drinking more alcohol, you're adding more of that diuretic into your system and you're going to pee more of that water out. Quite often, alcohols are often mixed with a whole bunch of other substances also. It doesn't matter what it is. If you're mixing an alcohol with anything, you're adding more substance, more solute into your body, which is also further changing that solute gradient. You're making yourself, say, saltier, or you're adding more sugars into your body system, which is going to dehydrate you more because your cells are going to take some of that water also. By the end of it, person goes to sleep at the end of the night. Sometimes they pass out because their body just doesn't want them to keep consuming alcohol. It just needs to retain that water. Because when you sleep, you have to use a large portion of that water also. And then that person will wake up and they'll have extreme pains or dizziness or that nausea. Sometimes they feel like getting sick. And so there's a couple of options that the person has. There is actually a cure for the hangover. A lot of people think it's more alcohol, which is not true. The alcohol is masking the actual effects of the hangover. It just makes things worse later on. The answer is water. It's not a quick cure. A person needs to rehydrate themselves Once they do so by the end of the day, they'll be back to normal. But that's the only way to avoid it. To avoid getting into situations of hangovers when a person does consume alcohol, a smart thing or a wise thing to do would be to consume an equal amount of water as whatever drink they've consumed. That way, when they do pee out their water reserves, they're also replenishing their water reserves by having some water with their beverage. Caffeine is similar, but caffeine is well, there is a difference, and the difference is that most of the time, and hopefully most of the time, when people drink caffeine, that's during the day as opposed to alcohol. It's during their work day or school day, whichever one they're working with, and it's very good. It has a lot of medicinal properties that help us stay alert and function as a part of society. The issue is that caffeine is also going to cause you to pee out. Um, the reason why caffeine's or another reason why caffeine's slightly different is quite often it's mixed in to create a coffee beverage, and coffee has a large water content, so you can balance that out. But a lot of coffee places offer various products that are not mostly coffee based. They're going to have caffeine, and then they're going to have sugars and sweeteners and creams and fats and all these different things. So, like going to say a Starbucks or a Tim Hortons or something like that, you're not just consuming caffeine; you're also consuming lots of solute and sugar and fat, which is pulling more water away from you into your cells. If you're just drinking coffee, it's not so bad, but you should try to have some water to counteract that later in the day. But it's not so much of an issue. One of the largest complaints that people have, medical pains that people can experience, are headaches. And it often does get tracked back to dehydration, especially if someone is working and they are consuming caffeine. They might get dehydrated a lot quicker than normal and they'll experience headaches while on the job. And instead of popping an Advil or a Tylenol, a better option would be to drink a glass of water because that can replenish those water reserves and then the headache tends to go away quite quickly. There is a third way that you can get a diuretic into your body, and those are the prescription drugs or things over the counter to promote more urination. It doesn't seem like it makes sense with the whole alcohol and caffeine situation, right? Hangovers, headaches, that kind of stuff. But if you do have a condition where you need to filter out your body, for instance, if you have kidney stones and we need you to pee more, we might give you some diuretic drugs to get that flowing through your body and flushing you out. But that is on advice of your doctor to get those into your system. Now, well, pardon me, I thought we talked about the acid base in the previous section. I guess we're going to talk about it here today. Acid base balance. We can manage the acids and bases in your body because we don't want too much acidity. That's going to cause your body from breaking itself down from the inside out, or a base, which kind of does the same thing. So, what our body does is it builds what's called a buffer system to prevent those strong acids and bases from damaging our body. Now, before talking about acids and bases in our body system, you should understand what an acid and a base is. Simply put, and we're not going to get into this in any more detail because it does get more complicated in this, but the simplest biochemistry that we'll get into is that if you have an excess H plus ion, H plus on the periodic table of elements is the most simple element you can find. H plus is therefore the simplest ion you can find. This is going to define an acid. If you have a substance that has an excess of H plus ions, you have an acid. The more H plus you have, the more acidic the material is going to be. The flip side is something basic. If you have something basic, you're talking about an OH negative ion. Something basic, the more OH negative you have, the more basic it's going to get. When you combine an acid and a base, an H and an OH, they combine to give you H2O. That is going to be water. That's why water is neutral in between acids and bases because it's a combination of the two. If you have something that's more acidic, you end up having a lower pH. If you have something that is basic, you have a higher pH. If you have water, your pH is going to be 7. We have in our body a buffer system. And the buffer system is to eat up any excess acid if we do get excess acid in our body, or eat up excess base in the event we get excess base. My expectation is not for you to understand the chemical equations. If you do, that's brilliant. But if not, I want you to recognize if you have an H plus ion, there is an equation where we're going to take bicarbonate. We're going to add bicarbonate, which your body is already retained. Combine that with the H plus, which is a strong acid, to create H2CO3. This is carbonic acid, which is a very weak acid. So yes, we mop up the acid by turning it into something much weaker so we don't get damage in our body. On the flip side, if you consume too much base, That base is going to combine with the carbonic acid to create bicarbonate and water. Bicarbonate we can use later on as a part of our buffer system, and water, of course, we can always use this. Essentially, what we're doing is we're taking a strong acid or base and converting it into a weak one. That way, there's less damage happening inside of our body, and that's how our buffer system is going to function. So, as you can see in this example, we've just got excess acid in our capillaries, so in our blood, acid gets pulled into your kidneys. Kidneys are going to release bicarbonate, and that's what the exchange is going to be. That acid then gets combined into something else to produce a waste product, but not a big deal because you're going to pee it out anyways. So, no big deal. And one other thing that you should be aware of with our pH regulation is how we can manipulate that. And the good news is it's actually your breathing. Okay, so way back when we talked about breathing in our respiratory system, we talked about how our hemoglobin can hold on to oxygen well, carbon dioxide not so well. But we didn't really talk about where the carbon dioxide goes. One of those places is into your urinary system because carbon dioxide, if you combine it with water, and I understand the arrows are all pointing to the right, but these arrows can go in both directions. If you take carbon dioxide and combine it with water, which we have plenty of in our body, that's how you create carbonic acid. If you break carbonic acid down, you get bicarbonate and hydrogen. So, as long as you are breathing, you will have a buffer system. There's a limit to it, sure, depending on how much you breathe. It's a limit to how much you can breathe. But as long as you are breathing and producing carbon dioxide, your body is going to have a buffer system because that carbon dioxide will bond with the water to produce carbonic acid. So you will always have that buffer system protecting you from damaging yourself from the inside out. Keep in mind, your kidneys are the only organ in your entire body that can do this. They're the only organ that can manage your pH. Yes, there are other organs that experience changes and fluctuations in pH. Most commonly, you'll think of your stomach, which has stomach acid in it, a pH of 2. But your stomach doesn't manage acid, it just combines, adds to the acid, or removes from the acid. It doesn't really manage anything. It's just your kidneys that are going to do this. And that is going to bring us into our final topic when we talk about illnesses, issues with your kidneys and how they function. And yeah, there's a lot. Okay. This isn't a comprehensive list. There are other things. There are some things that are inherited, things that are genetic, things like diabetes or hypertension, which if your family has it, there's a chance that you might have it. Or if you have bad health in terms of you're looking after yourself, you're not exercising, you're not eating properly, you can develop things like diabetes or hypertension. These are all issues of your kidneys, so we call them renal diseases. If you ever have some inflammation in your urethra, you get what's called urethritis. Not a great situation if this ever happens. You have to realize that the only way to get to your urethra, there's two ways actually. One is through your entire body system, but it's hard to get a drug through your entire body system. The other is to go right up into your urethra. So if there isn't ever an issue with your urethra, we have to enter your urethra and treat it right on spot. Same thing with cystitis. If this gets into your bladder, if you get an inflammation in your bladder, we can give you medication, sure, but remember your blood does not go into your kidney system, doesn't go into your urinary system. So we can't actually get the drug to you that way. The best way is, again, we go up the urethra directly into your bladder. That's the most accurate and quickest way we can give you the medication you need. So both of these are not great. They're quite invasive. You probably don't want to deal with those. We've also got pyelonephritis. This is infection in your kidneys. Fortunately and unfortunately, if something like this happens to you, you don't have to worry about things going up your urethra. Now we can operate directly on the kidneys, either through medication that comes in through your digestive system and then into your blood, or if it's really bad, we can operate. We can actually cut you open and access the kidneys. In worst case scenarios, we'll just replace them with another one if we have access. Another terrible one, it's probably the worst one on the list, is something called kidney stones. These are excess salt buildups, quite often calcium and sodium and other salts. If you have too much of those and too few water molecules, so you're not drinking enough water and staying hydrated, you will develop kidney stones. Kidney stones are terrible. They're rocks that are forming inside of your body, and apologies, the worst way to get them out is the only way to get them out. You have to pee these sharp, jagged rocks out of your urinary system. So you have to pee them so that they go through your ureters, they scratch up the inside of those, they end up in your bladder, and then they have to come through your urethra, scratching up the inside of your urethra. Very painful, quite often described as the second most painful medical condition that a person can have, second to childbirth. So Very, very intense. Especially bad for males because the urethra is significantly longer, so it has to travel through the urethra much longer. On top of that, you have to pee into a net because the only way you can see you've passed the kidney stones is by catching them in a net. So very awkward for the person to have to deal with that. Kidney stones can also cause a whole bunch of other issues like UTIs because you're scratching up the inside of your urethra. You can end up getting that inflammation in your urethra. You can get enlarged prostates, pH imbalances. There's a lot of different things that can cause that. Still gets worse. If you get a very large kidney stone, it's not going to fit in any of the tubes. They're not going to fit in your ureter. It's not going to fit in your urethra. So you have to get a treatment where we have to break down the rock quite often through some ultrasound. Problem with breaking down a rock is you turn one large rock into a bunch of small, tiny shards of rocks. You have to pee out more, and it's way more painful, but it's the only way of getting them out. If you ever do have a kidney disease, we look for a couple of different things. One of them is we find protein in your urine. Um, Amino acids make sense because you're peeing them out, but if we find proteins in your urine, there's an issue. They shouldn't be there. Or if we see blood. If you see blood in your urine, that's a big issue. So when you go to the doctors and they get you to pee in a cup, that's basically what they're looking for, is to see if you have any of those there. If they do, we know you have a kidney disorder, and we'll try to figure out what that is and then treat that as soon as possible. Another thing that we can do is give you a CAPD, which is a continuous ambulatory peritoneal dialysis, or just a hemodialysis, or just a dialysis. It's an artificial kidney. They're quite large. Quite often, they can be the size of an adult human. They hook up to your blood. It's again an artificial kidney. So if your kidneys aren't working, we can remove those, hook these up to you, or we can hook these up to you while you're waiting for a kidney transplant. Um, Good thing about kidney transplants, if it's someone close to you, like a relative, you tend to have a good success rate. The further removed that relative is, so instead of, say, your parents or your siblings, it becomes a first cousin, second cousin, so on and so forth. That success rate starts to fall down. But if you ever have an issue where a family member needs a kidney, has kidney disease, and if you have two healthy kidneys, it would be in their best interest if you were willing to donate that kidney to them because you only really need the one. But it's up to you. Just realize that people that are close to you, they will have much more success, and they'll avoid tissue rejection from your body parts than they would waiting for somebody else's. Just something to keep in mind. And that brings us to the last slide over here, where I'm just going to show you what the kidney machine looks like, what a dialysis looks like. So here we got this dude hooked up to a machine. You can't actually see the full machine. I've just got a drawing of what it looks like. But basically, his blood is hooked up to a pump, which is going to pump the blood through. And you can see that there's this big network that is built. And this would be into like this very large machine on the side. And what's happening here is this blood is flowing through, and it's being it's a dialysis machine basically. So you've got semi-permeable tubing, which allows some molecules to cross over the tubing. Some of them have to stay. Some of them end up into this used tube over here, which is basically for your urine, urea, that kind of stuff. So all your waste products, and any fresh dialysate is coming in. So any fresh fluids are coming in to help balance out um, that kidney. So it's just an artificial kidney that you can have. Off the topic of kidneys, as well, to point out, look at that sick mustache. That awesome. Anyways, I hope this was informing. I hope this was decent for the urinary system. At any time, if there are any questions, please do email me. I can help you out with working through some of this content. I understand some of the hormones get a little bit tricky to keep in mind and work through, but as long as we're sticking to it and trying to read through and trying to follow through, we should be able to work through that. So on your Google Classrooms, for those of you that are in the course, we've got the practice sheet with all of content on there. I'd like for you to try that out, and then eventually we will go over some of the solutions so you can see what's going on with that. But as mentioned, if there are any questions, please let me know. Other than that, I will see you for the next topic where we start the nervous system. We'll see you then.